what's happening is you've got a sailboat and it's going east. At how fast? 5 meters per second?
Yeah, 5 meters per second. And a gust of wind.
So a gust of wind comes, and which direction is it pointing?
The wind or the
The wind, yeah.
so it's 40 degrees north of east.
Right, so this wind comes and it's blowing this way. 40 degrees. Blowing like this. And it's 0.8.
Yeah.
So what is the wind going to do to the sailboat?
Kind of push it more north, east.
Right. So it'll change its speed,
North, I guess, 'cause it's already on east. But
and it'll kind of start turning it until it ends up going this way.
yeah.
So how do we figure out what it actually does? Like in total. Because it'll make it go north a little bit, but what will it do to its speed going east?
Kind of decrease. Going east.
Will it increase or will it decrease or will it increase? So the wind is kind of coming at it at an angle, but it's still pushing it, right? You can see that it's still pushing it this way.
Oh, yeah, to the east, northeast.
So in the end, it'll be going faster east, but it'll also be going north a little bit.
Yeah.
So this is kind of like, remember all those problems where we would take a velocity and it would be at 40 degrees. So this is like 30 meters per second.
Oh, yeah, it's just like the same thing.
Exactly, yeah.
Okay.
So in this case, you're going to take your acceleration, which is
0.8.
0.8, 40 degrees, and break it into components.
Okay.
So what's your x component?
It's going to be cosine. 40. Yeah. Sine.
So after 6 seconds of this acceleration, what will the change in velocity be?
6 seconds.
So this would be like change in velocity. What would be an x?
0.8 cosine 40.
So that's the acceleration. Then you do that for 6 seconds.
6 seconds. So you like times that by 6.
Yeah. So you take your acceleration, multiply it by 6, and you'll get, what is this, 4.8? So that's how much faster he's going in the east.
Okay.
And then how much faster would he be going towards the north?
4.8 sine 40.
So this would be the vector that you'll add on to this. So you know that under this acceleration for 6 seconds, his velocity will end up looking like this. You'll add this total velocity here. You'll draw your new one. But that's the same as if we did this, right? We just added on 4.8 cosine of 40 and 4.8 sine of 40. Right? Because our velocity initial in x was 5, velocity initial in y was 0, and our change in velocity x was 4.8 cosine of 40, change in velocity y 4.8 sine of 40. And then your final velocity is going to be, so typically change in velocity equals velocity final minus velocity initial. So instead we'll make velocity final equal change in velocity plus velocity initial. Okay.
Right.
So our final velocity, just add these two. So our final velocity x is 5 plus 4.8 cosine of 40. Final velocity in y is going to be 4.8 sine of 40. That gives you this vector right here, which is your total velocity. And if you wanted to find out the speed, what would you do?
So it's 0.8 meters per second squared.
You don't want to take, so we don't need to worry about our velocity or acceleration anymore, because we figured out what our change in velocity would be according to our acceleration. We've added that back onto our initial velocity. So this is our final velocity right here. This would be your x and this would be your y. So if you drew those out, it would be this one, right? So you'd have x and y is your total one. So this would be 5 plus 4.8 cosine of 40, whatever that number is. This would be 4.8 sine of 40. Then the total speed is the length of this one, right?
Oh, that vector.
So how do you find the length of that one?
You add those together.
Yeah. Yeah, it's the square root of the sum of squares, like Pythagorean's theorem.
So you do like 5 plus 4.8 cosine 40 squared
Right.
plus 4.8 sine 40 squared. That'll give you the hypotenuse.
Yeah. So I give you the hypotenuse squared, you just take the square root of that in the middle. Have your right answer. So that would be the speed. So if you could throw that in your calculator and figure it out really quick.
Eight point 677 for 5 plus 4.8. And you square that.
Yeah.
So it's like 7.8168.
This, well, you want to do this squared plus this squared, right?
Yeah.
So it's 4.8 sine of 40.
So C, and then you take a square root of C, right?
Uh-huh.
Well, those squared.
Right.
So C is gonna be, or the hypotenuse is gonna be 3.4327.
Hang on.
That'd be it, or?
Well, so that makes sense that this was 3.4 if this was 8.6. So our hypotenuse has got to be our longest leg. Is 3.42, is this 4.8 sine of 40?
What's that?
What's 4.8 times the sine of 40? So then what you want to do is do 3.08 squared plus 8.677 squared. And you just take the square root of that.
Oh, okay. Okay, that makes more sense. So this is 9.21.
So that's your speed, that's your total length of this vector. That's your speed, be 9.21 meters per second.
Okay.
And then it probably wants you to find an angle. So how'd you find that angle?
You do that. So you do. Do opposite over adjacent to find it.
Yeah, now that you have all three sides, you could use any of them. So you could do the inverse tangent of opposite over adjacent. Do the inverse cosine of the adjacent over the hypotenuse, or the inverse sine, whichever one you wanted to do.
Okay. So you do like 3.8 over 8.677.
Mm-hmm.
Give you that angle.
Well, that'll give you the tangent of the angle, so you do the inverse tangent.
Oh, sorry.
Because you know that, so if we call this theta, then tangent theta will be equal to 3.08 over 8.677.
So it's like about 19.543 degrees, so like 20 degrees.
Yeah, that makes sense. You have 8.67 over here and 3.08, so you know it's going to be less than 45. Probably about half that.